see the third question. The second one is same as the first one, so you can go through. The solution is there in the PDF. Now we'll see the third question. In free space z less than 0, a plane wave with hi equals 10 cos 10 raised to 8 minus beta zax milliampere per meter is incident normally on a lossless medium, epsilon equal to epsilon 0 mu 8 mu 0 in the region z greater than 0. Determine the reflected wave HR, ER and the transmitter AHD, ET. So first you have to understand the question, that is in free space a wave with HI is incident normally on a lossless medium. So the wave is traveling from free space to lossless medium. Also it is mentioned that free space is z less than 0 and lossless medium is z greater than 0. So if you take a boundary, like draw a boundary like this, and if this is z axis, this is z greater than 0 and this is z less than 0, then I can consider this as my first medium, that is free space medium, and this is my second medium, that is your lossless medium. Means the wave is traveling from the first medium to second medium. Next, what you have to understand is you have to find the direction of HI, EI and electromagnetic wave. So here it is beta Ez, so electromagnetic wave is along Z axis. Then here AX, that means magnetic field is along X axis, so obviously electric field is along Y axis. Now here I have drawn the diagram. Free space lossless medium, medium 1, 2, and the parameters are marked, and in medium 1 we have our incident ray and reflected wave, and in medium 2 we have transmitted wave. Okay, so we'll start with medium 1. Medium 1 is free space, so you know what is beta. Beta is equal to omega by c. Here the subscript 1 is used to identify that it is your first medium. Okay, so beta 1 equals omega by c. From the given question, omega is how much? 10 raised to 8. You will get it when you compare it with the standard equation. Okay, so 10 raised to 8 and c is 3 into 10 raised to 8, so we will get 1 by 3. Then we have to find out the intrinsic impedance of the first medium, eta 1, which is equal to 120 pi, because you know the intrinsic impedance of for a free space is 120 pi, and usually it is noted using eta naught. So the intrinsic impedance of our first medium is 120 pi, which is equal to eta naught. Now coming to the second medium, which is a lossless dielectric, you have the expression for propagation constant beta equals omega square root mu epsilon, and this 2 represent it is a second medium. So beta 2 equals omega square root of mu epsilon, and mu is equal to mu 0 mu r, epsilon 0 epsilon r. Then just splitting it, like writing like this, and you know c is 1 by square root of mu 0 epsilon 0, so I can write omega by c square root of mu r epsilon r. Now in the question it is given epsilon is equal to 2 epsilon 0, and you know what is epsilon? Epsilon is equal to epsilon 0 epsilon r. So when you cancel, you will get epsilon r is equal to 2, and in the question it is given mu is equal to 8 mu 0, and we have the expression for mu as mu 0 mu r, right? So mu 0 cancel, so you will get mu r is equal to 8. So that you can substitute in this expression. So finally you will get beta 2 equals 4 by 3. Now eta 2, that is you have to find out the intrinsic impedance of your second medium, which is given by square root of mu epsilon for your lossless medium, that is mu 0 mu r epsilon 0 epsilon r the whole root. Just I am splitting it. So this will give you, what is the square root of mu 0 epsilon 0, that is intrinsic impedance of free space, that is the expression of intrinsic impedance of your free space medium. that which is usually represented as eta naught. Then square root of mu r epsilon r. Then we have mu r and epsilon r value. You can substitute, and finally I will get eta 2 is equal to 2 eta naught. Okay. Now it is given h is equal to 10 into cos 10 raised to 8 t minus beta 1x milliampere per meter. You can compare it with your standard expression. H is equal to h I naught cos omega t minus beta 1 z ex. So what is h I naught? H I naught is 10. So what is E I naught? You have the expression E by h is equal to eta. So from that you can find E equal to eta into h. So here what is h? It is 10. And what is eta? It is eta naught. Okay. Here eta will be eta naught. This is your expression E I naught by h I naught is equal to eta. So which eta will you put? With eta naught or eta 2? Eta naught means the eta 1 or eta 2 you will put. It is eta naught because this is the magnetic field of your incident wave and this is the electric field of your incident wave, which always lies in your first medium, and in this question your first medium is free space. So E I naught by h I naught is equal to eta naught. From that E I naught is equal to eta naught into 10. Then what is E I? Okay, you got E I naught, then you can write E I is equal to what? E I naught cos omega t minus beta 1. Here you have to write beta 1 because EI is in your first medium. Beta 1 is at AY millivolt per meter. Right? Next. So you found out what is EI and what is HI. Okay, HI is given the question. Now you have found out EI. Now you have the relation connecting reflection coefficient ER0 and EI0 as ER0 by EI0 is equal to your reflection coefficient, which is given by the expression eta 2 minus eta 1 by eta 2 plus eta 1. Then you can write eta 2 and eta 1 in terms of eta 0, which gives 1 by 3. That is ER0 by EI0 equals 1 by 3. So from that what is ER0? ER0 is equal to 1 by 3 into EI0. So you got ER0. So you can find ER. What is ER? The general expression is ER cos omega t plus beta 1 Z. So the reflected wave is in your first medium. So beta 1 you have to write. And what is ER0? ER0 is 1 by 3 EI0. And what is EI0? EI0 is 10 eta naught. So when you substitute, finally this ER0 will be 1 by 3 into 10 eta naught. Then cos, what is omega? Omega is 10 raised to 80 plus what is beta 1? Beta 1 is 1 by 3 and is at A by m volt per meter. Now here you can see here listen, here EI you can see it is cos omega t minus beta. Here for ER it is cos omega t plus beta, because I told you earlier that if the wave is moving along the positive z axis, then the sign will be minus, and if it is moving along the negative axis, then it will be plus. And you know EI is, if EI is moving in this direction, ER will be moving in opposite direction. That is why here you have a plus sign. So this is the expression for ER. So if you have ER, you can find HR. What is it? ER by eta naught. You have to use eta naught because here it is reflected wave which is lying in your first medium. So you can substitute and find your HR. Next, you have the transmission coefficient tau as ET0 by EI0, which is given by 2 eta 2 by eta 1 plus eta 2, and which is connected to your reflection coefficient using the relation tau is equal to 1 plus your reflection coefficient. Okay. So we are using transmission coefficient T is equal to 1 plus tau, So here E T naught by E I naught. Instead of instead of tau, I will be substituting 1 plus your reflection coefficient, that is 1 plus reflection coefficient. Reflection coefficient we have already evaluated, that is 1 plus 1 by 3, that is 4 by 3 finally. So from that E T naught is equal to 4 by 3 E I naught. And what is E I naught? It is, I think it is 10, there it is, right, 10 eta naught. Okay. So you can substitute it. So finally you can find what is Et. Et is equal to Et naught cos omega t minus here beta 2, because transmitted wave is in your second medium. Beta 2 is at AY millivolt per meter, and you can you have the value of Et naught as 4 by 3 of Ei naught, and instead of Ei naught you can substitute 10 eta naught. Finally you will get the expression for Et. And if you know Et, what is Ht? Ht is equal to Et by eta 2. Eta 2 is the intrinsic impedance of your second medium. So what is eta 2? Eta 2 is equal to 2 eta naught. So you can substitute the value here. Here this eta naught and eta naught will get cancelled. Then this 2 and 4. So finally you will get 20 by 3 cos 10 raised to 80 minus 4 by 3 is a AX milliampere per meter. So hope it's clear, and thank you.